So class, now let us learn about derivative. So to learn about derivative, we start with a function f of x. And when you have a function, always you have a graph. And let us say that the graph looks like this on the screen. Now say, let us take a real number a on the x-axis. Now f of a will be the height of the line from the real number a to the point P. So that is f of a, and hence the coordinates of point P will be a, comma, f of a, x, comma, y. Now from the real number a on the x-axis, let us say we take a gap h. So on the right side of the real number a, you'll be having a number a plus h, because you have a gap h between a and the number a plus h. Now, the height of the vertical line from the real number a plus h to the point Q is represented by f of a plus h. So that is the height from the real number a plus h to the point Q. So point Q will have coordinates a plus h, comma, f of a plus h in the form of x, comma, y. Now, joining the points P and Q, you get a line which you call it a secant. A secant is a line which touches 2 points on the curve. So, after you have joined the points P and Q, then you will have the length of the gap from point Q to point R as f of a plus h minus f of a. So I think that is not difficult to understand. The gap QR is given as f of a plus h minus f of a. So that is the perpendicular of the triangle QPR, and h is the base. So when you take the perpendicular by the base, what do you get? So QR by PR, that is the slope of a secant PQ. Now, assuming that the gap h is becoming very small, h is approaching a number 0, because the length of a gap which is very minimum, very small, it can, at the most it is 0. So h is approaching a number 0. What will happen at that time? So point Q will slide down along the graph, and it will almost touch the point P. And at that time, you will not have the secant PQ any longer, but you will have the tangent. The tangent is a line with which touches the graph only at one point. So you will get the slope of the tangent. So here note the notation to represent the slope of the tangent at x equal to a for a given function f. So you have seen an example where you have taken a real number a on the x-axis. Now, if it is true for every real number x on the x-axis, then the slope of the tangent at any point can be represented by dy by dx, and it is called as the derivative of the given function f. So now, if you are given a function x squared, a function sine x, cos x, and tan x, so you have a graph of these functions, and you wanted to find out the slope of the tangent at any point on the x-axis. So you can find out that using the formula given in the line above, in the first line, and you will get the slope of the tangents as 2x cos x minus sin x sec square x respectively. That is if you use the formula given on the first line. Now, but it is up to you if you wanted to use the formula or if you simply by heart it and take those slopes as given on the screen.